Howdy! Welcome to our talk show. My name is Korok Ray. I'm a professor at Texas A&M and director of the Mays Innovation Research Center. Today we are delighted to have Jason Ballard join us here in Aggieland. Jason is the co-founder and CEO of Icon, one of the most interesting, fascinating, revolutionary, and disruptive construction technology companies around today. Jason is an Aggie, and he was formerly on the track team here at Texas A&M, majored in conservation biology, has a very interesting life story, and he's going to talk about Icon and about his time at Texas A&M. Welcome, Jason.
Happy to be here.
So, Jason, tell us a little bit about your company, which is like a rocket ship in the news. We've heard about it for some time. It's really taking off. Tell us in a little bit of a short description of what the company is and what it does.
Yeah, so Icon is a construction technologies company, and most notably known for inventing like construction scale 3D printing robots to reimagine the way that we build houses. The promise of 3D printing, right, is that it could go faster, it could be more affordable, it could expand design freedom, right? Because with a 3D printer, slopes and curves and all kind of fun shapes are just as easy as straight plumb lines. It has massive sustainability potential because the materials that we're building with are not only higher performing in the building itself, but there's also very little waste, right? With 3D printing, you print what you need to the drop, and then you stop. And that's cool, not just because it rhymes, that's cool because construction site waste is a major problem. It's massively scalable, so this is not just like a niche solution, it can be scaled potentially globally. And so when you marry all that together, speed, cost reduction, design freedom, sustainability, high performance building, scalability, I think this is the way we should be building in the future. I think it's time for the construction industry to join the digital automation revolution that has positively affected so many other sectors. And so that's what we're up to at Icon. We exist primarily in response to like the global housing crisis. There are far too many homeless people. It is far too expensive for the average human being to buy a home, especially for what they're getting, right? We don't love these homes. And so it wouldn't be neat if the houses of the future were a little different than the housing. It's actually an imperative that we do a better job at sheltering ourselves. It's a basic human need. Sorry, you asked for the short one, and I'm getting excited, but it's a really compelling body of work. And so robotics, material science, and software, and figuring out new ways to build things.
Wow, that's amazing. I mean, as you may know, construction is highly manual. It's a highly manual industry, and it's huge, right? It's huge across the world. Maybe you can show some photos of what this new technology looks like, and you can tell us a little bit about some of the open projects you have.
Yeah, so that project you're seeing there, that was the first 3D printed little community or neighborhood. We did that down in southern Mexico in partnership with a nonprofit called New Story, and their mission is to provide dignified housing for the world's sort of the global poor. And they were our very first customer, actually. So when I say like the global housing crisis is important to Icon, like that is absolutely where we started working. We were doing some like really interesting high-end houses these days to continue to explore the possibilities of the technology, but this is like right near our heart. Some notable things about this project, we printed these houses 2 at a time. So you could set up the printer because they're fairly close together. You could print them 2 at a time. And so at the end, we were averaging about 24 hours per house in terms of delivery speed. And the other notable thing about this is these houses were designed for earthquakes because this is a seismic zone. And already this area has received a magnitude 7.2 or 3, I think, earthquake that caused like extensive regional damage. And there's not a single hint of damage to these 3D printed houses. And so the folks who are living and moving into these houses now, they are the descendants of like the Mayan people. They don't refer to themselves as Mayans anymore. They call themselves the people. But the story of the indigenous communities in Mexico is a very sad one, much like the story of the indigenous communities in America and Canada. They didn't have a reservation system. They often lived in like informal housing and river drainages and stuff that would be subject to flooding. And it's incredible. This project was actually featured on an Apple documentary series called Home. So if you want to learn more about it, you can watch that episode. It will make you cry. It makes me cry, and it makes me proud of the work that we do. So anyway,
that's
a very
outstanding.
Cool project. Yeah,
that's outstanding. Those houses look beautiful, and we can see these lines in the picture. That's the 3D printed structure.
That's right. That's right. And as you can imagine, again, we're like very, very proud of this project. But this was 2 years ago now. And so like we've only gotten better and faster and more accurate, and things have only continued to improve from there. But we were very proud of this project. And I'm very proud that our very first like scaled project, again, was like in the service of the very poor.
Great.
So
that's great. That's great. And that's core to your mission, right?
Yeah, that's exactly right. I mean, the big ideas that Icon can is like, because shelter is such a basic human need, if you fundamentally reimagine it, you don't get like minor consequences, you get massive consequences, right? And so like we've just embraced that and sort of made it part of our mission. Like we exist to put this technology in service to humanity, both in solving the biggest problems that you can possibly tackle with construction, but also to open up these like grand opportunities, like maybe becoming like a spacefaring civilization and some of these kinds of things, which I'm sure we'll talk about a little bit later. Yeah,
that's right. So what's this?
So this picture, this was the original rendering, and I don't know if you guys have the actual finished product. The headline is, "The finished product like looks this good." These were the first 3D printed houses for sale at market rates in the world. So we built these houses with a developer partner of ours called 3 Strands in Austin. They're like kind of an infill developer. They buy lots and they sort of increase density to, as a, you know, hopefully to, at a macro level, make houses more affordable. And so this was our first like commercial project for targeting the mainstream in America. These houses went for sale last week, actually. So 2 of them have already sold. 2 of them are still for sale. This was notable for a number of reasons that maybe will sound boring to your audience, but just to give you a sense of like how all the kinds of complex problems you have to solve when you solve a big problem. We needed to know that insurance underwriters and appraisers would appraise a 3D printed home valued at hundreds of thousands of dollars. We needed to know that people could get mortgages on 3D printed houses. Like, will banks loan against a house that like people haven't seen before to the tune of hundreds of thousands of dollars? And so those things have now been verified, which is incredible, because we had to go through all the testing for the permitting authorities, the appraising districts, the mortgage makers, et cetera, et cetera. And so those are like real milestones that we had to achieve if this technology is going to achieve its like maximum promise. Right. And so we did it. And then the other, from an engineering perspective, thing that you'll see this house did, the first story was 3D printed, but the second story was built conventionally. And that was like very much on purpose. We wanted to validate that our wall system was sufficient for multi-story buildings. And you can model it in software and you can model it in the lab and in testing. But there's only one way to really know, and that's to do it, and then to test it. And so now that we know our wall system is indeed verified sufficient for multi-story buildings, that will give us the courage to begin working on multi-story printing technologies. And that's important because the majority of the houses built in the world actually are at least 2 stories. And so if we're really going to be serious about solving the global housing crisis, you know, up and down the market, we have to get serious about multi-story printing. So this is our first validation of that. So it's an incredible project.
Yeah, absolutely. Are you printing just the perimeter of walls or the interior also?
Yeah. As you can see there's some pictures. So this project was actually a series of 7 homes we did for people experiencing chronic homelessness in Austin, Texas. So we printed 7 houses in partnership with Community First Village. So this is a house that like a person who was formerly homeless lives in now. Wow. The other options would have been like used trailer houses or sleeping under bridges or something. And so like, I mean, every college student probably watch, like you'd be like really happy to live in this. Like I would be happy. I have a family of 6, it's my wife and I and 4 kids, so we wouldn't fit in this house. But like, this was a revelation that you could provide housing at this level of dignity and quality for people who had been experiencing homelessness. And as you can see, there's another good shot of it. We print the interior walls also. So what we deliver right now in the automation is the wall system. And the reason we could have started with, when you talk about like construction robotics, it's like, where do you even start? And it felt like the wall system was the most powerful automation to start with because it's the most materials and labor intensive. So typically in a wall system, you have framers and insulators and sheetrock guys and siding guys and painters and all this stuff. And so with one automation, we can replace all of that. And so that makes it faster and cheaper. And so in other words, you're not just getting framing, you're getting all of that with an Icon wall system. When we show up and print a house, you are getting structure, you are getting interior and exterior finishing service, you're getting insulation, you're getting plumbing and electrical rough-in are delivered in the print. And so that's what makes it such a powerful, from an economic and speed perspective, such a powerful automation. And then sort of at a more human level, the reason it's such a powerful automation is because the walls create like the shape and feeling of the house, right?
Yeah.
And 3D printing opens up these like very interesting possibilities
Right.
for shapes and structures. And so all that put together, it was just like, it was a no-brainer that this was the automation to start with. But we're not done yet, right? The reason we call ourselves a construction technologies company instead of a 3D printing company is because 3D printing is just where it all started. But we think we have a lot of fun stuff yet to do. This is more of that same project. You can see these houses were printed 3 at a time with one printer. Set the printer up, it prints 3 houses at a time.
Right.
And then all 3 houses had a different floor plan. So if you printed 100 homes in a row, all 100 can be different because it's just software, right? It's the first digitally native approach to construction that I'm aware of.
Right.
And so this also opens up this possibility, like as the technology scales, the ability to not have these like cookie cutter developments that we're all like very familiar with. And sort of cookie cutter is usually used as a pejorative. Yeah, it's like it's not a compliment. But it's not because those developers are bad people. That was the only way to economically make it work.
Yeah.
With the current paradigm. Is you have to like repeat the same things over and over again, or the price of housing would be even worse, right? It's like we're forced into these bad corners because that's the only way we know to do it with the current paradigm. And so the paradigm has to change, sort of back to where I started here.
Yeah.
We don't need to do things a little bit different. Like things are really problematic right now, and so we need to do them like very, very differently.
We need a 0 to 1 change.
We need a 0 to 1 once in 1,000 years. We've been building homes, this is not CEO hyperbole, the same way for 1,000 years. If you look at a picture of a 1,000-year-old house, no kidding, look it up. If somebody ever Google 1,000-year-old house right now, it is bricks or stones and mortar and timber.
Right.
It's the same thing for 1,000 years. We figured out how to like use like nail guns and a few other things along the way, but it's the same thing.
Right.
How many, I mean like, we're the most advanced civilization on this planet. Like, how many other things have been the same for 1,000 years? Like, maybe like bread making or something. But even that, we do it in an oven instead of over a fire mostly now. And so it's like, it's time to like take the next step. And I think that next step is going to open up. I know I've already said this, but I want to say it again. Is going to bring us into a totally new like echelon of civilization. In the sense, like, I think the very same level of civilization that solves homelessness is the same one that will build the moon base. And I think those things happen together, right? It will take that kind of thinking to get us to the moon, or the moon kind of thinking to help us solve homelessness on Earth.
Okay.
So that's it.
Let me add, so it sounds like you're innovating at least 2 different margins on both the technology of the robots themselves, but also materials.
Correct.
Right? So tell us, I mean, you know, in America at least, a lot of traditional houses is framed in wood.
Correct.
And now you're using concrete.
Correct.
So tell us a little bit about that. Has that been an uphill battle, or that's?
It certainly has been the most, like probably some of the most difficult technical challenges have been on the material science front, because we need concrete to do different things than we're used to making concrete do. Like, and I'll say something about that in a second, but let me back up a minute. Like, we chose concrete. Like, we had our choice. We could have done like exotic polymers. We could have done foam. We could have done like all sort of interesting things. Concrete is a remarkable material, and it does the things from a first principles perspective. It does the things you want a building material to do. Right. And wood does not. Wood, it was sort of almost an accident of history that we live on a planet with lots of trees, and we could get them for the most part. And it had some things going for it, most notably like good like tensile strength. But wood wants to burn. It wants to. It wants to conduct heat. It's a conductor. It makes it feel worse in the house than it would with other materials. It wants to be termite food. It wants to be mold food. It wants to rot if it gets wet. And so you're always fighting against the nature of wood. Again, what it has going for it's good tension strength or tensile strength. And it's beautiful. Wood is beautiful.
Yeah.
Concrete, by comparison, is inherently very strong. It does not want to burn. Very difficult to set concrete on fire. It does not, termites cannot eat it. Mold cannot eat it.
Right.
It has high thermal mass, which actually creates building comfort and energy efficiency. And so when you use concrete, you're like cooperating with the material and what it wants to do. So why haven't we been using concrete all along?
Right. Why
Great
not?
question. Because you typically need a lot of form work to build with concrete, and that makes it even slower and even more expensive. But with 3D printing, the printed, what we call extrudable concrete, becomes the form. And so you can have all the advantages of concrete without the manual labor, without the slowdown, without the cost of conventional formwork. And so that's the big breakthrough from like a construction science perspective. Is like we developed a kind of concrete that can become formwork, basically.
Okay.
And so...
and you guys are processing your own patented concrete? Is that right? Your own kind of concrete?
It's proprietary. There's different ways to like hold intellectual property. And it is our proprietary concrete. Our highest concentration of PhDs, and we have PhDs throughout the company. We have PhDs in mechanical engineering, we have PhDs in software, we have PhDs in material science. Our highest concentration of PhDs at Icon is in material science because this is the most vexing problem. And so our joke is like, this is the Manhattan Project for the future of concrete.
Right.
And we've been tackling it very, very hard. And I'm like so very proud of our progress. But again, we're only a 3.5-year-old company. Like we have so much yet to do. Yeah. What we've already done is good enough for the market. Like it's ready to begin scaling and to begin building more of these homes. But we have like so many more advances even to make even yet.
And just so our audience is aware, so you've raised about at least $250 million for the company,
Correct.
and you have over 100 plus employees.
Correct.
In Austin, but you're growing fast.
Growing like mad.
500. You're going to hire 500 in the next
So I think in like the first quarter of this year, we were around like 30 or 40 people. Yeah. We're like 115 or 120 this week. We bring on like a new class every Monday. We have like around a dozen people that start every Monday.
Yeah.
And that's going to keep going. So we'll be at about 250 or so a year from now. And the plan is, based on printer capacity in the business we've already lined up. I think we'll be closer to 500 people a year after that.
Wow.
So,
and where is Icon in the kind of the landscape of construction tech? I mean, in terms of the other companies, is there a second best competing alternative that you know of?
Yeah, we certainly think we're the leaders in what we do. Yeah. I don't spend a lot of time like analyzing the competition because like I know what our problems are and I know what we need to solve vis-a-vis our customers, like what our customers need from us, and so that gives us plenty to do. I'm usually like very glad to hear there's like other people working on various approaches to the housing crisis. Like it's the largest industry in the world, the construction industry is. Right. And so I think there's plenty of room to innovate and for other folks to be doing things. And so there are some other notable companies doing interesting things. We wish them the best. But I think like our nearest competitor has built 2, maybe 3 houses. And we've built several dozen, or we'll be building several hundred in the coming year. Okay, great. And so I think we're like an order of magnitude, or maybe 2 orders of magnitude further down the road than anybody else. That's largely due. Like I wish the whole team was on the show. Like you would not believe the people who have like signed up for this project. Yeah. It would like make you proud to be a human. That like people who could be working at Google or Tesla or SpaceX or all these other like exciting companies have instead come to Icon. And are using their gifts and talents in the service of this like big ambitious mission. Like I said, we have like over a dozen PhDs. I think there's like 12 ex-CEOs that work at Icon. Wow. So it is just like a powerhouse of talent. And like, so it's like, well, how did you get so far ahead so fast in just 3.5 years? It's like, it's the people. Like a company, at the end of the day, is just a group of people who decide to do something. And if I could give any advice to, if you're going to start a company, if you're going to join a company, like, think long and hard about the people you're working with and around. And the Iconics, that's what we call our employees, are the most impressive group of humans I've ever had the privilege, maybe other than attending Texas A&M University. It's just the most, and there's a lot of Aggies at Icon.
Right. Oh, good.
And
good.
So,
and hopefully more.
Yeah, there will be more. Come on. Yeah, we're waiting.
So looking ahead, do you see yourself becoming a national home builder or feeding materials and technologies to the existing home builders? What do you think?
What a great question. So the thing that comes before anything else at Icon truly is this mission about solving the global housing crisis or making the biggest possible dent in it. And we've tried to like quantify that because it's a fun thing to say and it makes people feel good on like your shows like this to hear things like that. The size of the problem is like approximately 1 billion homes. Right. If you sort of add up houses we have to replace, houses for homeless people, replacing informal housing with formal, dignified housing, the obsolescence of current housing. So if you add all that up, how many houses do we need? Order of magnitude is 1 billion. I've heard estimates as high as 1.2 to 1.3 billion. I've heard them as low as like 800 million, but it's like about 1 billion.
It's a lot of homes.
It's a depressing number of homes. In fact, to make it even scarier, just to like translate what 1 billion means, if we built 1 million homes per year. No one on earth builds 1 million homes a year. No one. No company in the history of the world builds 1 million homes per year. Even at that rate, it would take you 1,000 years. That's like 950 years too long. like precisely. Yeah. And so that mission in like figuring out how to get to 1 billion. The technology needs to be responsible for the delivery of 1 billion homes in my lifetime. Wow. The joke is we can build 1 billion homes and then Jason can die. That's like, it's like the funny joke inside of Icon now. Yeah. It's a big challenge, and I can't see a way of solving that problem without putting the technology into the hands of other people. Right? Like we're going to have to conscript other people into this mission. But like, man, that sounds like a lot of fun, right? Like I can't wait to see what like African architects and builders and Middle Eastern architects and builders and Asian architects and builders and people from the Latin countries, architects and builders, like when everybody else can sort of own and put their own fingerprints on this technology, when they can design digitally and build from local materials resources. I mean, it's like a very exciting problem. But it means we're going to have to run it like in an incredibly high speed for the next 50 years to even have a shot. Because I don't know if you know anything about like compound. I'm sure you know a lot about compound interest. I don't mean to say that like that. If you think about compound interest, even missing 1 year has like downstream effects. Like we have to stay on track. And we have to stay on track for the next 50 years to even have a shot. Like even missing 1 year by like 5% makes the cone of probability go the wrong way. And it's very hard to catch back up.
So now, home building is very much kind of a local industry across the world. How are you going to kind of distribute your technology globally? Can you connect the dots for us?
Yeah, I can paint like a broad picture because again, we're like 3.5 years old, so we think we know directionally where we are headed, and a lot of the details will get sharper as we get closer to them. Like any other journey you make in life, you can see the mountains off in the distance, and you know you're going toward the mountains, but the trees come into focus when you get a little closer. I think some ideas that I think are helpful are like service areas. Right? It's very difficult to like put a printer and print crews like out on an island. And we've had to do that for a few projects we've done so far. But things go faster and cheaper when there's like a robust support network at hand. And so I think the rollout would like happen like in the framework of like a service area. It's like now in the Colorado service area or Gulf Coast service area or UAE service area or Indian service area. Like these kinds of things would be like the way to think about it. Like there's just, because it's a built world kind of thing and not software at the end of the day, it is of its nature geographically bound. The printer has to get there on a truck. We have to build out of real physical things. That's right. And so I think the expansion will take a very geographical shape. And that's how it'll go. But then if I'd be like going to an area and then inviting the builders and developers and architects of that area to sort of join the Icon mission, right? To adopt this technology and to let's do this together. But we're looking forward to reciprocally learning how we can serve those communities as well, right? Like this you've heard me say it a few times already, but this like posture of service. This is a technology we're putting in service to the world. And when we have customers, it won't be this like, the idea is that it wouldn't be this like very heavy-handed, do what I say. It's like, how can this technology be used to serve you and the needs of your community and your business and things like that. So that would be the posture.
Interesting. Yeah, just thinking out loud, it reminds me a little bit about the evolution of computer technology around the world. And there was sort of the debate between the closed versus the open system, Apple being more of a closed system, the PC being more open. Do you have any thoughts on any preference there?
Yeah, I think my answer is like in the middle. So it turns out, the technology itself will be very closed, right? You do not modify a printer because people's lives are at stake. If it doesn't print right and a house collapses, that's not cool. Whereas like if a piece of software breaks because you were hacking on it, like you just try again. You can't hack on somebody's house, at least not with the same audacity. So the hardware, the software, and the materials, like you must use our material because that's the only one that we validated. So that part is closed. And then even furthermore, it does matter to me what our technology is used to produce. And so there will be some amount of like verification of like architecture and building design, not to limit creativity, but because like I don't want people using our technology to build inferior housing products. Right? Like I don't want them cutting corners. I don't want them skimping on the foundation, these sorts of things. I mean, these things are like biblically problematic, right? Right? Like you don't build on a bad foundation. And so there will be like some control that is exerted in areas related to human safety, human dignity, sustainability, these kind of things. But when it comes to like creativity and stuff, that we want to be very open. I sort of like, I'm sure you saw the movie like Black Panther. Like the Wakandan architecture was incredibly inspiring. And I just saw Shang-Chi at the movie, and like some of the sort of fantasy realms. They were like the Asian influence on the architecture is incredibly beautiful. It's like part of the richness of being part of the human family, or these like variety of cultural expression. And so 3D printing makes that easier. Right, because like straight from your imagination to a built thing, the structural engineers need to sign off and the material scientists need to, but like truly we're about like removing barriers to that creativity. So
something I thought about, and I recommend anyone listening, just go to YouTube. If you put in Jason's name, you'll see he's got a bunch of other interviews. And when I was watching this, I was thinking about the history of innovation of before, just in the U.S. Before we had radio, people had newspapers, right?
Yes.
And when they first invented the radio, they didn't know what to do exactly, so they just kind of read newspapers out loud.
Yes.
And it took time before they adapted to, let's have actually a radio show.
That's funny.
And then when the TV came along, when they first had the TV, it was just people talking to each other as if it was a video recording of a radio show.
Yes.
And then it took time to adapt to, here, there are things that we can do now as in a TV. So I'm sure you know where this is going. What are those? Tell us about that translation from kind of traditional stick and bricks architecture to now 3D printing. What new opportunities is that transitioning happening?
Yeah, it's happening, and slowly. It's first happening on architecture, and I think next up it's going to happen on products. And here's what I mean by that. Like when we first sort of announced our existence in March of 2018. And we had a 3D printed prototype house in Austin, Texas, still standing there.
Yeah.
That was the first permitted 3D printed building in America. We would sort of get all these requests of like people would like send us pictures of their house or pictures of their designs and like, can you guys print this? But as you mentioned, they were all like normal houses. They were squares. It was like a bunch of boxes. And it was like, well, I can, but like it seems like a bit of a shame.
Right.
To like use this advanced technology to do just like a carbon copy of like what you're used to.
Right.
And so we eventually, when we would try to like encourage our customers to be like a little bit more creative and see like what boundaries we could push, what we finally realized is it's probably unfair to ask customers to innovate at great expense on your behalf. And so we actually launched this series of homes. The first one is now public. We call it like our exploration series, where like we are buying land and we are hiring world-class architects to help us explore new design languages, new architectural vernaculars for 3D printing houses. The first one we just announced is called House Zero. If you like Google icon House Zero, you'll see pictures of it. It was designed by Lake Flato, who I think is one of the top architects in America and in Texas. It has these like tree walls and it's like interesting usage. Matter of fact, the long main entrance of the house, there's not a straight line that you can see. But also you'll see like it's very recognizably like it's a house. It's not a spaceship. It's a house like you would want to live in it. And so we're doing this we have more houses to come in this series that we haven't announced yet, and I won't be announcing on today's show. But it's these collaborations with world-class architects to explore these architectural boundaries that I hope over in time it'd be nice if like we could quit doing that. Like people would sort of like, oh, I see. Like entirely new things are possible. So that's the like architectural explorations. The other half is like the product. So right now what we've had to do is like, here's our windows. You need to make them fit into your 3D printed building. But the windows were designed to be fit into a stick frame building.
Right.
And so I hope as we gain market traction and market acceptance, eventually window manufacturers, coatings manufacturers, plumbing, electrical folks will come to us and say, how can, like your category is exploding. How can we design windows specifically for 3D printed houses?
So you want the whole supply chain to kind of adapt over time.
If we're going to build 1 billion houses, it better.
Yeah, that's
right.
Exactly
like and everybody wins, right? It'd be like an explosive growth opportunity.
Just as happened with cell phones, right? Once the smartphone came around, the entire supply chain.
Africa skipped landlines, right? They went sort of straight to cell phone, and so. There's something like that. Yeah. Once upon a time, the transportation economy was like horseshoes and bridles and all these sorts of, buggy whips that people needed to support that transportation economy. And then a whole new economy emerged to support the automobile. Matter of fact, a whole new way of planning the surface of the earth emerged for automobiles, interstate systems and things like that. So I think not to be, well, actually to be hyperbolic, except if I'm exaggerating, I'm not consciously exaggerating. This is that kind of paradigm shift.
Yeah.
Switching to robotic construction is just as big a deal for the future, and the way humans experience the surface of the earth in their own communities is as big a deal as the automobile. It will change the way cities are designed, the way neighborhoods feel and look, and it might even, our first home on another world is not going to be built by a framer. It's going to be built by a robot. Right. So when we build the moon base, when we go to Mars, and we want to build things, not carry things with us, when we want to build things, they'll be built by robots.
Yeah. Let me just tell you, Jason came to campus yesterday for being a judge on our 3D printing design competition to build out a robotics lab on campus. And we saw a little bit of that in the submissions yesterday, that there were some designs that were more traditional and others that were really engaging the printer in a novel way.
Yeah,
right? So that'll take time for people to
that's right. We saw this exact, and so we saw what I just described there over the last 3 years. That was our experience at Icon. I saw it like in a microcosm.
Yeah.
Everyone got that they had like novel opportunities because of 3D printing. So people realized we have better insulation and we have better comfort. We have all these things. Not everybody realized, we're not stuck in rectangles anymore. Like we sort of have these other really interesting opportunities. And so I was super honored and inspired actually to see the work of those teams, and I'm looking forward to A&M and other universities like digging in on this. I hope there's a class here at A&M one day in the architecture school for designing for 3D printing. I hope there's a class in the construction sciences program I hope you guys have an Icon printer, and there's a way to like design a curriculum around fielding and operating construction robots.
That's right.
So
let's talk about the final frontier.
Let's talk about it.
Let's talk about it. So tell us how this emerged as out of Icon. What you can disclose about what you're doing, the unique challenges you're facing going to space.
So most of my career I've spent in like housing and construction or around there. Even though my undergrad was in biology, it was sort of the emphasis in conservation, which is a program I don't think exists here anymore, sadly. But I've been mostly in construction housing, so that was like the provocation for the existence of the company. But while I was starting the company, I was also working on my graduate studies at the Colorado School of Mines in their Space Resources program, Masters of Science in Space Resources, which is all about human economy and humans in space, right? Like using the resources of space to do all kinds of things, whether in orbit or on the moon or Mars or other planetary bodies. And so it was just in my brain. And it was very clear, like as I'm thinking about housing on Earth while getting a graduate degree in space resources, it was like, oh man, when we go to the moon, there's just no Home Depots. There's just not. And even if there were, you would not want to expose astronauts to the dangers and hazards of the hard vacuum and radiation environment of space if you didn't have to. The robots can go first and build things ahead of the humans. There's sort of all these advantages, and I could go on the list. And it was just like, this is going to be it's a very long game, but this is going to be one of the most important applications of this technology. And it just so happened in the year that we launched the company that NASA had launched a Martian 3D printed habitat challenge. They were inviting private companies and universities from around the country to participate in this challenge. And so we did, but very much is almost like an afterthought because we were so focused on the news story projects, and we were a small company. At the time, we were like paying for it with our own credit cards. God bless my wife. But we participated in the challenge, and we were a finalist and an award winner in the contest. And so that established a relationship with us for NASA. And then, of course, in the intervening years, NASA has gotten more and more serious about the Artemis program and returning to the moon, to stay. Not just a camping trip, not just a flag planting expedition, although I think the Apollo programs are probably the most inspiring thing that humanity has ever pulled off. I challenge you to find like a more like when you think like we left the planet in like so NASA's realized they're going to need these like construction technologies, and so we are now working with the Marshall Space Flight Center on the development of a lunar printer that needs to also then be modifiable to use on Mars. And so that printer, we call our Earth printer Vulcan, and that printer is called the Olympus system. So we call it Project Olympus. And then also right now we're working with the Johnson Space Center. We are literally this week putting the finishing touches. Like as we sit here, I'm going tomorrow to Johnson Space Center. We're putting the finishing touches on a Martian analog habitat, a habitat built the way you would build it on Mars. And they're going to have crew live in it for a year at a time. 1,500 square feet, locked in for a year, 8-minute communications delay, no windows, just to start beginning to understand the psychological and health effects on humans of being on long duration space travel. And so 30 years from now, when we look at pictures of NASA getting ready to go to Mars, that work is taking place inside of an Icon building, built with an Icon printer, and designed by Bjarke Ingels Group, like the #1 architect in the world. And so it's an incredible project. And so I think the chessboard is set up really well for us to be like way out front on like lunar and Martian construction capabilities. Very technically complex, like the hardest construction project humanity's ever imagined. So I don't want to minimize the challenges, but I really like the way things are shaping up. And there's no law of physics reason that this can't happen. It's about willpower, funding, and just the courage to see it through. Wow. So it's very exciting.
That is exciting.
We're presently scheduled to have Icon hardware in space in the next 2 years and on the lunar surface in the middle of this decade.
Wow.
So not in the far, far future. Like you could watch on TV a rocket go up in the air and know that there's an Icon payload on board bound for the moon. Wow. Like before this decade is out. And that's very, very cool.
Wow. Yeah. Amazing. So the center, the Maze Innovation Research Center, is some of you may or may not know, we are dedicated to understanding and studying innovation. So you're the great case study. I want to kind of steer the conversation a little bit into the genesis of Icon. And you can start as early as you'd like. Yeah. But we want to imagine, a lot of students are going to be listening to you and want to understand what were sort of the things that happened, maybe distinguish between what was accidental, what was deliberate, to make those critical early moments successful.
Yeah, I will start early, especially given this audience. Yeah. I grew up in small town Southeast Texas. My address was in Orange. My high school was Bridge City. And it's in a geographic region known as the Big Thicket. And this is going to be important. I'm not just indulging myself, or maybe I am, but it'll still be important. Big Thicket is the most biodiverse region of all of North America. So there were like roseate spoonbills and alligator gar and 4 species of carnivorous plant. It was an amazing place to grow up. Yeah. It's also one of the largest concentrations of petrochemical refineries in the world. And so there's signs up around town. They're like, do not eat the fish in this water. And classmates of mine at my very small high school had cancer. And so it's like, I grew up being exposed to sort of the sacredness of the natural world, but also the desecration of the natural world. But also like, all my family was employed by the petrochemical industry. So I wasn't like mad about it per se. It was just like, this is what put food on the table and a roof over my head. But it was a sense of like, even as an 8th grader, you're just asking bigger questions than an 8th grader is supposed to ask. And so it's like, we've got to be better at this. And so I came to Texas A&M and that's what I wanted to do. I wanted to work in biology and fisheries and wildlife to like be better stewards of the natural world. What turns out, if you say like, where are all these problems coming from? It was the built environment. It wasn't all the things that I had been told at the time. It wasn't gas guzzling SUVs and private jets, or whatever. Yeah. It was buildings. Buildings are the #1 user of energy, #2 user of water. Construction is the #1 producer of landfill waste. #1 user of almost every single natural resource category. The #1 user is the construction industry. It's like, my gosh, like I don't need to be a field biologist. Like I need to be working on buildings. And so I had a huge life pivot.
When was that? When would you make that pivot?
Right as I graduated A&M, and thank you for saying that, because A&M reinforced all of this for me. Like going to school here, it's just in the air that we are citizens and are responsible to this world beyond our own like happiness and fulfillment or whatever. Right. It's just like really reinforced that like we sort of like we have responsibilities to this world. And then I was also a part of the Aggie Men's Club, which sort of turned Aggie values like up to 11 even, which was like we did service project. It was like talked about every week in our weekly meetings. I mean, I love a good whiskey or a beer or a glass of wine, but there's like no drinking at Aggie Men's Club meetings. And it was because like it was a sense of like being sober-minded and having like serious conversations about, and we had a lot of fun too, like don't get me wrong. Yeah. But my whole like experience at A&M was like, how do I be in service to this world? And like, what are my responsibilities with the gifts and talents I have to serve my sister and brother? Yeah. And that affected the way I thought about what career to do and how to live my life. And that's one of the like wonderful things at A&M. I don't know a lot of, to diverge for a minute. Like, I think there was like some yelling or trash talking or whatever at the football game 2 weeks ago. And then the head yell leader I saw released this letter that said, hey, Ags, we don't do that. Yeah. Like, that's not what we do. Like And like, I hope I get to meet the head yellow leader. Like, what a remarkable thing to do in this day and age. To call for civility and kindness. And I was just so impressed. But that's the kind of thing that happens at A&M. It's also like, of course the head yell leader did that. That's just what Aggies do. And so that shaped what kind of business I went into. And so that led to me starting one business that worked in sustainable building materials and technologies and services called Treehouse.
So a lot of students might be a little nervous about jumping from a biology major into a field not directly connected to biology. That jump was. Did you have any trepidation about that, or how would you? If a student was in that position today, what would you tell them?
I think one of the things A&M did well for me. Number one, I had like a STEM degree. And so I understood like the basic premises of like, it's pretty easy to jump from physics to chemistry to biology if you're paying attention. But I also took a number of like philosophy and liberal arts classes and learned about. And logic was a really fun class where it was like how to think well, how to reason well. It's like, these are the benefits of a university education on its face. Like, it's the reason you go to a university instead of a trade school. I think trade schools are awesome. I think way more people should consider them. But if you chose a university, one of the things you're here to do is to learn to think and reason and to be more broad-minded about things. And there's this big pressure to specialize, but that's not actually the thesis of a university. It's the reason we have all these colleges and departments. And so I think that kind of broad-minded university education actually served me well in that regard. Is like, I was able to level up on a topic very confidently and very quickly. And learning to do that was a thing I picked up here at A&M.
That's great.
It was great, and I wish it was more. I don't think that's always true of people's university experience, but I wish it was. And so what I would tell students is like, don't sleep on your basics. Everybody's like, oh yeah, you get these big like freshman level 300-person classes. Like, you just kind of got to get through them. They're weed out classes, whatever. And the important stuff happens your junior and senior. It's like, no way. What I am actually drawing on today as a CEO of a company are my freshman and sophomore classes. Ecology 101, physics, chemistry, basic biology. Like, that's the stuff that has served me well for a long, long time. It's some of the specialized stuff that like hasn't proved so useful in later life. And so like, don't sleep on your freshman and sophomore classes. Like, those are like the ones that are going to be with you for a really long time and will form a foundation for either graduate studies or your career later on. So that's a piece of advice.
And so you started Treehouse, is that?
Started Treehouse, and it was all about sustainable building products and technologies and services. And it was cool, and I think we did a lot of good in the world, but we were still like tinkering around on houses as they exist. And I remember coming home from work one day and saying like, honey, this is like not working. It was working in the sense that like people were buying our stuff, but it was not working in the sense of like, we're not making the world more sustainable, not fast enough. And there's all these like $1 million houses that in Austin that need like a lot of work to become efficient. It's like, it would just dawn on me like, we're building houses the wrong way. You shouldn't have to do this much work on a 5-year-old house. It shouldn't be this bad. We're building wrong in the first instance. And so I just set up a little research project and called up my old Aggie co-founder of Treehouse, a guy named Evan Loomis. He graduated from the Mays Business School.
Oh, great.
And he and I started like evaluating all the different, what could we do if not the way we've been doing it? So we looked at modular houses and prefab houses and shipping container houses and zip panels and SIP panels and insulated concrete forms. Probably the craziest thing we looked at was like architectural fungus. I don't recommend it, but it was only 3D printing that had it wasn't clear it was possible, but it had the possibility of being faster, cheaper, more sustainable, more resilient, more design freedom.
So this was early 2017?
This would have been like 2015 is when I first discussed the idea with my wife. 2016 was the first time I discussed it with Evan. And
where was 3D printing at that time? What was it?
It was a science project. There were some universities doing things, and in fact, our other co-founder, Alex, who's from Baylor, was a mechanical engineer from Baylor. He was also almost on the exact same timeline. We just hadn't met yet. He was building and testing prototypes. He had come at it from the robotics angle, right? Like I sort of came at it from this like housing angle. Like, we're not building houses the right way. He came at it from this mechanical engineering perspective of like, these desktop 3D printers, this is the wrong application. Because people were like saying, this is going to be a revolution. And he was going, well, like, they keep printing spoons and coffee cups, but like coffee cups and spoons are already cheap and widely available, like a misapplication of the technology. And he was like, the right application of this technology is not at a desktop level, it's at a very large level. And he was totally right.
It's kind of the reverse of computing, right? Computing started out very big and then it's just gotten smaller and smaller.
And
this one was the reverse.
Yeah, right? It's sort of like 3D printing is most powerful on things that are slow, expensive, and bespoke.
Yeah.
If something is all three of those things, then 3D printing can come very powerfully. But if something is small, cheap, and mass produced, 3D printing is not disruptive at all. It is slower and more expensive.
Right.
And so Alex had the insight that this is a complete misapplication of this technology, and we need to be building these things much bigger. And so it was like Evan from business school, Jason from like this housing and construction sustainability background, then Alex from this robotics mechanical engineering. And it was just like a perfect recipe for co-founders. Like all of us had very different skill sets. All of us were coming at it from very different angles, had very different superpowers is the way we talk about it. And it was just, it's been a dynamite partnership.
Wow. And then you guys set out to build the first.
And so I met Alex through a woman named Samantha Snabes, who's a former NASA engineer who now runs her own large 3D printing company called Re3D. You can look them up. But Samantha, I was meeting with anybody who worked in 3D printing because I was trying to level myself up, biologist. And I needed to learn. So I was reading every book I could find, meeting every 3D printing person I could find. And I met with Samantha and she said, there's another person in the state of Texas working on this, and his name is Alex, and he's from Baylor, and you guys should meet. So Samantha introduced Alex and I, and we just started like meeting up like once a month or so. First just me and Alex, and eventually me, Alex, and Evan. And eventually it was like, we should all be, at first it was just like this little nerdy meetup where we were just talking about what we're working on, what we're thinking about. And eventually it was like, we should all be working together. And so Alex moved to Austin and we formed the partnership. Within 6 months, had our first customer. I didn't even have a printer yet,
Were you still
but got
at
a
Treehouse
customer.
at the time, I guess?
I was still the CEO of Treehouse, correct.
This is like your side project, right?
Yeah, so, I first brought this up to the board of Treehouse. And they were like, Jason, we love you, but that's not what we do. That's not our business here. And it was sort of like, well, permission to work on it nights and weekends, basically. And I did, so it was like a nights and weekends project. I have pictures of me and my kiddos in their soccer uniforms. After their games on Saturdays, we would go over to a warehouse in West Austin and work on the prototype. It was just a thing I did on nights and weekends. And then eventually there was like a big decision, whether to stay at Treehouse or whether to commit myself to Icon. And I thought, because of the potential revolution that Icon could represent, that was the right, but it was not easy. That was a really hard decision.
What stage was Icon in at that time?
We hadn't even raised money.
But you had a product? You had a printer?
So we had a customer, so we sort of self-funded all the way through that first house you saw. We got a customer news story, but they wanted us to prove we could do it before they paid us to go down to Mexico to do the Mexican project that you saw. And so we built that prototype house in East Austin, had to get it permitted, had to like really treat it like a proper house. And we did, and that's when we announced our existence to the world. We hadn't raised any money, and that was the moment where it was like, okay, I have a decision to make. And so I left Treehouse, and became the CEO of Icon instead of at Treehouse, and raised our seed round at that time. And that was, 3.5 years ago. And the rest is kind of history,
So again, sorry to keep going deep on this, but a 3D, tell us as much as you can disclose, a 3D printer that's printing on a desktop a piece of Legos, to kind of printing a house. What are some of the intellectual challenges or jumps you have to make to what changes?
Other than the basics of like motion in three-dimensional space. So we did use we chose a gantry format, and I don't know if this is we evaluated robotic arms, towers. We did choose the gantry, and so the kinematics, the robotic motion of a gantry is very similar to the kinematics of a desktop printer, but the material's totally different. There are some analogs to the software, but a desktop printer doesn't care a lot what's going on interior. We carry a whole lot about what's going on in the interior. Like there's electrical wires and plumbing inside. And so only in the broadest brushstrokes was there a ton of overlap. Everything's had to be kind of invented from whole cloth. We had to create our own software, had to make concrete do things it's never done. Like desktop 3D printers use metal or plastics of some kind. That's the material science of metals and concrete are quite different. And so it was a complete, we had to innovate on everything. And we've sort of always raised more money than our size and stage of our business would indicate. I think we raised $7.5 million in our seed round. And seed rounds are usually $1 or $2 million. It's like, well, every time investors are like, why so much for a seed round or a Series A or a Series B? It's like, because we're not a software company. This is a properly sized seed round.
This is capital
for giant robots. Like if you want to build giant robots, a prototype is $7 million. It's just what it is. And there were enough investors who believed in the mission and believed in the progress we had made to take the bet. And we're very grateful to those people, because I think now we're ready to graduate from homes by the dozen. We've done 24 homes. And we're ready to graduate from homes by the dozen to homes by the hundred. You will see some announcements in the coming weeks and months about some very ambitious projects that we're super, super excited about. Yeah.
Okay. What's been in this journey, this icon journey that you've been on? Tell maybe if you can go into maybe one hard decision you made, or a major battle, a hill you had to climb that was very hard and that was interesting for you.
Probably the scariest decision. Well, I'll pick one where I think I was right, because I've of course made some wrong decisions. One that I think that I was right, but it was very scary to make, was actually the decision not to focus. Because we have very large contracts with the Department of Defense, with NASA, and doing housing, residential housing. There's a very strong argument to be made, and maybe Icon still would have lived and existed if, like, you should just focus on the housing. And so there's a decision, but we had these offers from the Department of Defense and from NASA, and there was this discussions like, is this a distraction or is this good? And we ended up deciding to do all three, even though they're slightly divergent, because related to the ultimate mission of housing, we needed to mature this technology as fast as possible. If you only work in construction, you only make so much money, you only have so much profit margins, and you only can make so much progress on the technology as a result, that actually serves the big mission more poorly. And so by working with the Department of Defense and with NASA, especially in the early days, a lot of their funding was research-oriented funding, right? It wasn't construction projects. I mean, we have done some, but it's a lot of it's just research-oriented funding. It's like anything that will mature this technology faster. Even if it means we kind of have to walk and chew bubblegum at the same time. But that's not the right answer for every startup. In fact, I think the default answer that startups should focus is actually true. I think in this very unique case, we were an exception. But it was a very scary decision because we were still small. We were like 15 people. It's like we're going to tackle 3 giant projects or like focus like crazy on housing. And we decided to say yes to NASA and the Department of Defense. And in retrospect, it's right. Like that additional funding helped us mature the technology. It's why we're ahead of our competitors, and it's why we're able to now build such elegant houses. Our houses would be worse without NASA. Right? What an interesting thing to discover. But it was not obvious at the time, and it was a scary thing to do. And if I was wrong, it could have been like existentially wrong. It was a very scary decision.
Wow. You touched on this a little bit, but looking back at your career, what parts of your time at A&M, I know you talked about the broadness and the general education, were the most valuable to you, or you can answer that either in terms of the education, the Aggie values, whatever.
I think what A&M did for me, as I've met other people from other universities, that like they don't appear to get. They're often like, man, you had such a cool. A&M did an incredible job of creating an ecosystem and an environment to fully form me as a human, not just as a brain, but as a brain, as a heart, as a body, right? I ran track. I was in Aggie Men's Club. I did a lot of social service, and it's very easy to do social service. It might even be hard to go to A&M and do no social service. It's like very, very hard. But I bet it's easy at a lot of other colleges to not think twice about community service and like what your career and your education means in light of the world. It's very hard to ignore those questions at A&M. And so like I left A&M, I think, is a very fully formed human. And that's related to those values actually being practiced. It's related to sort of like, it's very hard to go to A&M and only go to class. You're sort of expected to join these other things. And I'm slightly introverted on the scale. And so there's a world where I could have run track and gone to class and been perfectly happy. And I think that a good broad university education mixed with like the social community culture of A&M set me up to lead. I mean, Icon's a very complex, very dynamic business. I mean, there's like 1 minute I'm in a mechanical engineering meeting, the next minute I'm meeting with senators, the next minute I'm like trying to sell to a customer, and tomorrow I've got to go to NASA and then do a radio interview. It's just like, it's a very dynamic, complex job. And I think A&M equipped me with all the tools necessary to succeed at this job. I have there's a group of 20 of us that meet once a year. We went to all different colleges, and we still meet once a year from our time at A&M because we felt like something special had happened here. We said we don't want to do the normal thing, which is like we see each other once every 10 years after this. And so we made a commitment at graduation to meet once a year. We've been meeting once a year for 16, 17 years now, 20 of us. And people, and we're all deeply friends. Most of them were my groomsmen in my wedding and things like that. And people I've met from other universities have said like, that did not happen to me at college. Like I didn't leave it. But I think it's like quite common for these bonds of friendship to last from A&M in a way that you know, it's not a scientific study, but like I've had plenty of people come to me and go, what did you guys do? Like what happened? Like people have noticed it and asked. So something special here.
So to the students watching, what one piece of advice would you give to them at this point in time, looking forward into their careers and their lives?
Well, you already got a bonus piece of advice. It's like take your basic courses incredibly seriously. No kidding, that's a huge piece of advice. Don't sleep through them. The second one is like embrace that particular genius from A&M, which would like allow yourself to be fully formed. Like get uncomfortable, make the time, stay up late. Like you'll never have less obligations, believe it or not, than you do right now. You think you're so busy, you're not. Like wait till you have a family and debt and a mortgage and a job and stakeholders. This is the time to invest in yourself. And so join the clubs, do the service, go to the games, like drink it in and like be a part of the human experience at A&M. Those values are real. The reason they have lasted this long and the reason people keep saying them without laughing is because they're serious and they work. And they form good humans that are capable of leading countries, leading companies, solving problems, and creating opportunity. And so drink it up. Like don't treat this like a community college where you just like show up, you go to your class and you go home. Like really drink it up. And do it. Yes is more at A&M. Like do all of the things. That's my advice.
So to the students in the audience, you know, I've been in higher education my whole career. One thing I've noticed about Jason, that one way he's very gifted, and I think this could be an example to all of you, is that you're very fearless in approaching and attacking the biggest problems of the day. And I think that's a great lesson for all the students, that you shouldn't shy away from asking the biggest and the hardest questions, because you only live once and this is your time on earth to make a difference. And so I hope that the students watching could draw some inspiration for all your work, because you are doing the Lord's work.
Well, thank you, man. I hope that's true. That's my prayer for sure. But he's exactly right. I mean, this is not a dress rehearsal. You're in the play and nobody else can play you. So get out there and do it.
That's right. All right, gig 'em. So thanks for watching. Okay, thanks a lot, Jason. Thank you for showing up.
Of course.
Yeah.
Bye.